All right, so in our previous example, we saw a question where it's a quadratic trig formula, or trig equation. And so we had to use the idea of factoring to get to the same steps that we had from yesterday. So really, this isn't a big jump in that, it's just grade 10 factoring that we have here. And so once we get down to the factors, the rest of the question is just like what we did yesterday. So not too big a jump. So how could we make this a little bit more like a grade 12 question? So that's where we would do example 2. So I'll give you a second to write that down. It's 2 cos 2 theta minus, 2x minus 2 sine x. So this doesn't look like a quadratic. I don't see any x squareds. But what I do see is a cos 2x. And we know that cos 2x is a double angle. And we have double angle formulas then to deal with that. So this is how this question become a little bit more like a grade 12 question. So we have 2 times cos 2x. Well, I can use any of the 3 possibilities for the double angle formula, but I think the one I'm going to use is the sine squared one, because I've got a sine over here, and I think I can change this into a quadratic trig equation. So I'm going to use the third of the double angles that are probably written on the board for you. So 1 minus 2 sine squared x. I could have used the cos squared one, I could have used the cos squared sine squared one, but you see how that would get me further away from something that's usable? Whereas this one, this is, I replaced cos 2x with this version because now I've got a sine and a sine. And it's starting to now look like a quadratic trig equation. This first part is being multiplied by 2, so I'm going to rainbow the 2. That's going to be 2 minus 4 sine squared x minus 2 sine x. Starting to look more like a quadratic trig equation, but for quadratics we usually like to have the x squared first. So I'm going to put the negative 4 sine squared x first, then the x one, which is just negative 2 sine x, and then I'll just have this plus 2 at the end, just changing the order. Now this looks almost like the quadratic that I could factor, but remember I'm not a fan of having the first number to be a. I don't like having that a value to be negative, and I'm also noticing that I've got a 4, a 2, and a 2, so I could make my life a little bit easier by dividing everything by negative 2. I see negative 2 is common for everything. Well, 2 is common for everything, but if I divide it by a negative, then this negative at the beginning will change into a positive because I'm dividing it by a negative. So if I divide by negative 2, I then will have 2 sine 2x plus sine x minus 1 equals 0. And now it looks like the quadratic trig equations that I'd done before. In fact, it almost looks exactly like example 1. But if you look closely, you'll see example 1 was 2 sine squared minus sine x minus 1. This is 2 sine squared x plus sine x minus 1. But I'm still going to do the thinking. I'm going to think like grade 10 and change it to x's because it's a little easier for me to see the factoring I need to do when it's in x's. Again, TV tray, got to serve up a 1, 2, 1, 1, 1. I need a positive 2 and a negative 1 to get that. So this will be 2x minus 1 this time. And x plus 1 equals 0. I was just using that as a little crutch to be able to see the factoring, but now I think I can factor it in with the signs in it. So this becomes 2 sine x minus 1 and sine x plus 1 equals 0. Each of those then can go to B0. So this one would be 2 sine x minus 1 equals 0. Hopefully you don't mind if I add 1 to both sides and divide by 2 all in one step. It'd be a positive, and then divide by 2 is sine x equals 1/2. And then this one is sine x plus 1 equals 0. So I want to know when sine x equals -1. And the rest of this question is going to be almost identical to what we did in the last video. But of course now the sine x is positive, and it's -1 instead. So I'm going to quickly buzz through the last part because it's the same as the question we did in a second, and it's also what we did yesterday. So when is sine positive? If you were with me in my last video, I made this mistake, but I'm not going to make it today. So when is sine positive? It's positive in the first and second quadrant. I'll get 2 answers, one that's here, one that's here. I'll go to my calculator for some help, and it's going to tell me 0.5, or sorry, 30 degrees. It's 0.5, and then you do second function sine. That's 30 degrees, which is one of my answers. That's 30. This must be 30. So our x is 30, or 180 minus 30, 150. Think in radians as pi over 6, pi over 6. And my one answer is pi over 6, or a full rotation, or a full half rotation, I guess, is pi. So 6 pi over 6. Take away 1 to get back here is 5 pi over 6. Then in the second half here, remember that only tells me the ones that are going to get me 1/2. I also want to know the values for x that will get me a -1. And again, this is not going to be in any quadrant. If you go to your calculator, you'll see it's 90 degrees, or not 90 degrees. It's 270, right? Because the picture told me that. So I didn't even need to go to the calculator to know I was wrong there. When is it -1? It's right here, which is 270, or 3 pi over 2. And so the answer from this guy is 3 pi over 2. And I'll finish then with my solution set as pi over 6, 5 pi over 6, and 3 pi over 2. In general, we would add 2n pi to each of those. Okay, so again, we're just slowly building on the same concept over and over again. This stuff at the bottom here, this is all what we did yesterday. The factoring is what we just did in example 1. And all that's different in this question is using the double angle formula to make it look like a quadratic trig function. So that's kind of fun. And we'll do one more, and then I'll let you go off and do some practice. So the last one we're going to do is sine squared equals 2 plus sine theta. This doesn't look much different. I'm not going to have to use any double angles. I'm not going to have to use any compound angle formulas or anything like that. And it does remind me of one thing. I see that it is sine squared, so I see that it's x squared equals 2 plus x. And it does remind me, though, in grade 10, when I'm solving quadratics, the strategy is to set it equal to 0 and then factor. So I'm going to have to bring this across to x squared minus x minus 2 equals 0. So that helped me visualize what I need to do over here. So sine squared theta minus sine theta equals, minus 2. Then I'm going to go back to my little rough notes there. And I got a factor. Well, this is an easier factor. What two numbers multiply to -2 and add to 1? So that's -2 and +1. So again, using this little scrap off to the side is really handy to allow me to factor the quadratic trig equation, sine theta -2 and sine theta +1 equals 0. So we're going to then, of course, set each of these equal to 0. Sine theta -2 equals 0. Sine theta +1 equals 0. Isolate for sine theta. And I want to know the value of when sine theta is equal to 2. Well, if I stop and think about that, sine theta is just a graph that goes like that, and it never gets to 2. If there was a different amplitude, it might, but there is no time when sine theta equals 2. So this is not possible. And this wouldn't be the first time that we would have a factor that doesn't result in an answer. We've seen that before when we might be taking like the square root of a negative number. We know we can't do that. So it's not surprising that we get situations like this that'll pop up where part of the answer is not possible, so there is no value for theta to actually solve that. Now what about the second half? Well, this one is a little bit more possible because it's sine theta equals -1. Draw my picture for this guy. And it's just like the one I just did. When is it -1? Right there at 3 pi over 2. And so theta equals 3 pi over 2. So I didn't have to do much more in this because the numbers were either not possible or very simple. And so my solution set, there's only one possible answer to make this one true. 3 pi over 2. And in general, 3 pi over 2 plus 2n pi. All right. So hopefully I've shown you enough examples that allow you to try and do some practice of these solving trigonometric quadratic trig equations. And so there's some practice on page 436, number 7, A to D, and number 9, D. Good luck.